when any number, we want to make sure that we're lighting up the decimals. This is true for whole numbers or for numbers that we already see the decimal. So as we look at number 1, 5 times 10 to the third power plus 6 times 10 to the third power, we can add those together because they have the same power of 10, or multiple of 10. So if we write them out, 5 times 10 to the third power in the standard form, we would get our 3 zeros, so 5,000. And if we have 6 times 10 to the third power, we'd write it out in standard form as 6,000. To add those, we're really just adding the numbers that were in front. So 5 plus 6, 11. And then we have our zeros behind. So if we go back up into our problem, what we see is that the 5 here is really just being added with the 6 here, because the powers of 10 are the same. They act as like a like denominator, or even like a variable in some cases. So what happens if we don't have like denominators or the same variable? So here we have 10 to the third power, but here we have 10 to the second power. So to be able to line these up, we have here 5,000, and this is 600 in standard form. We want to be able to show that it actually is able to be lined up, so we can just add. So what I need to do here is I need to actually change this part to being a like exponent. So in the sense that it's the same, 10 to the third power, or I could change the other 10 to the third power here with my first term and make it 10 to the second power. So take a look at see how this works. So here, if I want to make this 10 to the third power, 10 to the third power, then it still has to equal 600. So where would my decimal have to go? It'd have to move one more place to the right. So in order for that to happen, I'd have to put my decimal behind it, or in front, depending on how you're seeing it, but to the left. I'd have to move it one more place to the left so that it could move 3 places, 1, 2, 3 now, and still end up in the same position it did originally. So now with the fact that I have this 10 to the third power, I can rewrite this in the form of 6/10 now times 10 to the third power. Now I have the same power. I have 10 to the third power, 10 to the third power. And here, all I have to do is look at my term in the front with its term in the front and add together. So if I do that, I have 5 and 6/10 times 10 to the third power. Now putting that into standard form, I could say, well, move the decimal 3 places. So moving it 3 places, I get 2 zeros, and there's my final answer. Looking back up here, 5,000 plus 600 gives me the same thing. So that 5 plus 6 would not have given me my 5,600. I would have had to make sure that I moved the decimal first to give myself the same power of 10. So 10 to the third power, now 10 to the third power. Moving the decimal as needed. Looking at our last example, we have negatives. This negative exponent, remember, is going to tell us to move our decimal to the left. So let's look at see what that looks like first before we start playing around with moving the decimal and changing the power of 10. So 1 and 5/10, we're going to move that 3 places to the right, or left. So I fill in 2 zeros. So my actual answer is going to be here, 15 10,000ths. Now on this side I have 3 and 1/10, moving it twice to the left. So 1 0. So I have 31 thousandths. That's a little bit different. I want to make sure that they line up. So this time what I'm going to do is I'm actually going to change my first term. So before I started up here and changed my second term to make sure that it had the same power or exponent of 10s. Here I want to change my power of -3 to make it a power of -2. So where would I have to move my decimal so that it only moves 2 places? So here again, I want to make sure that it ends up at the end here. So if I go back 2, so once I found it in the standard form, it's pretty easy to go backwards 2. Here I go 1, 2. And there, if you see that it actually gets moved again in the front. So because it's moving the other direction, I have to move it back 2 places. So in this place, in this example, I want to make sure that I move it 1, not a very good arrow, there we go, back 1. So I should really have 15, or 15 hundredths, times 10 to the negative 2 power. Okay, at this point, because they now have the same power of 10, I can just line them up and add them. So I can actually line up the decimals, and in this case it's actually subtracting, so I'm going to be saying subtract. So 3, because it's going to be the larger of the two, subtract, put my 0 in here, I guess that's 11, so that was 10. So here we have 10 minus 5 is 5, 10 minus 1 is 9, 2 minus 0 is nothing. So there we have it. We have 2 and 95 hundredths. But again, we had, this was the greater of the two values, and so I'm going to have negative 2 and 95 hundredths times 10 to the negative 2 power. And I have to stay with that negative 2 power because of the fact that that's what I used to be able to relate them so that I could line up the decimals when I was adding or subtracting. This is a new concept, so make sure that if you have any questions, you're bringing them to class. We'll definitely be using this more this year.